trigonometric function. Then after that, we conclude with exponential function. So for trig function, we're going to consider sine, cos, and tan. I hope you're following, right?
Yeah.
Good. So that's going to be 2a. I give you y to be equal to sine f of x. And I say you should find dy dx. Dy dx will be equal to... Now let me ask you this question, Kandeli. What made this function a trig function? What made it a trigonometric function? Sine f of x.
Sine.
You are very correct. So that sine is the major function. Are you getting me right? Are you following?
Yes.
Automatically f of x becomes the minor function as usual. Sine is the major. So all you have to do is differentiate the major, differentiate the minor, multiply them. Remember I told you apart from this first function polynomial, the rest, I would like to present the derivative of the minor first before derivative of the major. So we go. dy dx is equal to differentiate the minor. We don't know what that f of x is. It can be anything. You wait until your examiner gives you a question. Then you now identify the minor. So this is going to be differentiate with respect to x. Whatever the minor function is. Then times. Go ahead and differentiate the major. Derivative of the major. Differentiating the major is the main thing here. Because that's the main function that we are focusing on here. And this is where calculus becomes even much more simpler. Did you know? If you're asked to differentiate sine, if you differentiate sine, you don't bother yourself. It will simply change to cos. If you now want to bother yourself, you want to punish yourself, how come did sine change to cos? Then you go back to first principle, that formula will derive. Then use it to determine how sine changed to cos if you are differentiating it. But this is an interesting thing about calculus, at least at this level, and even at lower level in university, for example. You are not asked to derive that guy. You are never asked to do that. You are not. That is why we have this standard. And in any calculus textbook, after the noise making of first principle, yeah, I use that word, the next thing you enter quickly are the standard derivatives. And when you start solving questions, it is the standard derivatives. This thing I'm listing here, that is what you use in solving the questions. So why would somebody say that this is difficult? So let us go. If you differentiate sine, it will give you what I said, cos.
Cos.
So all you have to do, derivative of the major, we change to cos. Once you differentiate sine and it gives you cos, remember, cos cannot stand alone. All your trig functions, sine, cos, tan, cosec, cot, sec, and whatever, they can't stand on their own. They always carry an angle in front. They always carry something in front of them. We call that thing their argument. We call it their what?
Argument.
Good, their argument. And the argument is always the original minor function. The original minor function from the question. That is the argument. That is what will now be in front of that cos. So I'll simply put f of x. So this is the standard derivative of sine of a function. If, for example, I give you y equal to sine x, the one that textbooks we usually use as standard, they'll tell you that if you have y equal to sine x, then dy dx is equal to cos x. I don't like using that to teach standard. I don't like, and I've proven it beyond reasonable doubt, that although it is not wrong for that to be taught, however, I think with the progression in knowledge and the advancement in ways of doing things, teaching standard derivatives with all these things, this format, it limits students' knowledge. It reduces their level of understanding of calculus. It's one of the things I've found out that makes students to complain about calculus. Because when they teach with all these simple concepts, like all these standards, using x, in all cases, they blind students from understanding that, you can be given something of this form, where the minor function is no longer ordinary x. Don't worry, as you progress in your studies, you will encounter this I'm talking about, but I will expose some of them to you, even at this level. Now look at this y equal to sine x. If I say you should differentiate to be dy dx equal to, what is the minor function here, Candeli? Minor function, what is it?
X.
You are very correct. If you differentiate x, what will you get?
1.
You are very correct because it is in its basic form. And I told you, whenever the minor function is in basic form, you don't need to differentiate. You don't need to differentiate it. It's a waste of time. You're going to get 1. So we are going to multiply this by differentiate the major function. The major function here is what?
Sine.
If you differentiate sine, what will you get?
Cos.
Now, if you write the cos, do you leave it like that?
No.
What must be in front of it, which is the argument?
X.
You are very correct. If you simplify this, 1 times cos x will give you what?
Cos X.
So dy dx, if I give you y to be sine x, and I say you should differentiate, dy dx will give you cos x. In many textbooks, and when many other persons teach this concept of calculus, the standard that they use, usually in the case of sine, is this simplest form, which is what forces them to bring in what we call function of function that introduces chain rule. It's still okay, but I am advocating that we go beyond that. If somebody can understand the interpretation of this, it's best we use f of x as a minor function instead of just using x alone, because it limits students' knowledge. Do you understand this? This is the dy dx that we've done for sin x. Do you understand this?
Yes, sir.
Okay, what if you were now given this y to be equal to sine x raised to power 2? Y to be equal to sine x raised to power 2. All you just have to remember always is your standard, and have exposed the standard to you using the concept of what I always advocate, the major minor. GMAT 41 for years have been advocating that. In our YouTube channel, in the GMAT 41 YouTube channel, my calculus works, that's the standard I use in teaching. And many students, they've been enjoying this standard. People that pass through me, every single one of them will always tell you that calculus is really very simple. Okay, look at this. Let us get the dy dx without wasting time. What is the minor function here?
X.
Is the minor function still in its basic form, like when you are reading your ABCD? Is it still in that basic form?
Yeah.
No. So you must differentiate it. You do the derivative of the minor here. If you differentiate x squared, remember that x squared is of this form now. It's polynomial function related. Is that not so?
Yes, sir.
So if you differentiate x squared, what will you get, Kamdeli?
You get 2x.
You are very correct. 2x. Use the power, multiply the base, go to the power, subtract 1. Now, the major function is sine. If you differentiate sine, what will you get?
Cos.
Simple, without wasting your time. Cos. And what will be the argument of that cos?
X squared.
You are very correct. Squared x there. And that is the answer. With this approach, by the time I will introduce you to the concept of function, where we'll apply chain rule, because chain rule is one of the concepts of rules of differentiation. You will love it. Nothing is there to become quite simple. Okay, let us move on to the next function. With the understanding of this sign, you have learned everything about differentiation. Although you have not seen all the types of function, you have not. There are about 17 functions whose standard you are meant to learn. But hey, not at this level yet, so I won't stress you deep into them all. For now, we're going to limit our coverage to the things, the functions that you likely are going to meet if you are to be tested on calculus. So let us look at 2b.